Are the answers to homework number 5. Check them out. All right, and we will work through them. In problem number 1, you just need to substitute the ordered pair in for x and y and see if it works. So I would put 4 in for y and -1 in for x. That would give me 4 is less than -2 plus 5, or 4 is less than 3. And that is obviously false, so no, it's not a solution. Number 2. If you were to graph that, do you shade above or below? Well, when it's in slope-intercept form, the less than or greater than sign tells you whether to shade above or below. And when it's less than, you would shade below. Again, that's because of the less than. All right, number 3 is already in slope-intercept form, so I can go ahead and graph the y-intercept at 3. And the slope is down 2, right 1. And I can go ahead and draw my line. The or equal to makes it a solid line. And because it is less than, I'm going to shade below. And I'm done. Number 4, to graph this line, this is the line x equals -1. And because of the inequality sign, it is a dashed line, so I'm going to have a dashed vertical line at x equals -1. And if I test the point 0, 0, putting 0 in for x, 0 is less than -1, that is false. So the answers are on this side of the line, and I'm going to shade in that side of the line. Number 5, to graph that, I'd probably put it in slope-intercept form. So I would subtract 3x from both sides, giving me -4y equals -3x plus 8. I'd then divide everything by -4. That gives me y equals +3/4 x minus 2. So this is the line that I am graphing. And that is going to go up 3, right 4. The y-intercept was -2, right? And then the slope is up 3, right 4. Because of the original inequality, I'm going to have a dashed line. And then I need to shade. Lots of people get this one shaded incorrectly. There are 2 ways you could shade it. One, you could pick a point, like I could pick the point 0, 0. And say 3 times 0 minus 4 times 0 is greater than 8. That'd be 0 is greater than 8, which is false. So I'd be shading below the line. 0 is on the wrong side of the line. You know, a lot of people get this one wrong because when they put it in slope-intercept form, they keep the inequality. And when they divide by -4 to put it in slope-intercept form, they forget that when you divide by a negative, you have to flip the inequality. Oops. And so you get 3/4 x minus 2. And since the inequality is less than, I would be shading below the line. Number 6, I need to write an equation for this line. Well, let's see. The y-intercept is -1. So the slope of this line is up 1, right 2, so the slope is 1/2, and the y-intercept is -1. That's the equation for the line. Now all I need to do is I need to figure out, instead of an equal sign, what inequality should go there. Well, since it's a, my choices are these. Since it's a dashed line, I can get rid of these. And since it is shaded below the line, this must be the one. All right. Number 7, write an inequality that describes the region of the coordinate plane that is not included in the graph. So, for instance, if I took this and I graphed it, it might look something like this. Oops, except it would be a dashed line. There we go. It's a dashed line because of the less than. So the numbers that are not included, the ones that are not included would be the numbers on the line and this side of the line. So the numbers not included would be the numbers that are greater than or equal to 5x plus 1. There we go, kind of. All right, our most difficult problem is the story problem. A truck that can carry no more than 6,400 pounds, that's important, is being used to transport refrigerators and upright pianos. Each refrigerator weighs 250 pounds, and each piano weighs 475 pounds. Write and graph an inequality, show how many refrigerators and how many pianos the truck could carry. All right, so I'm going to have X be the number of refrigerators, and I'm going to have Y be the number of pianos that the truck can carry. So I'm going to go ahead and label my graph now. X is the number of refrigerators, and Y is the number of pianos. And I want to go ahead and write an inequality. My inequality, let's see. Well, I know that the truck has, I know I can carry less than or equal to 6,400 pounds. The refrigerators weigh 250 pounds each, and I've got X of them, so 250 times X would be the weight of the refrigerators. And the pianos weigh 475 pounds, and I've got Y of them. So 475 times Y would be the weight of the pianos. And all that weight, the refrigerators plus the pianos, needs to equal less than 6,400 pounds. So there's my equation, or inequality. I'm ready to graph that now. And if I were going to graph that, because it's in standard form, I'd go ahead and use the X and Y intercepts. So the x-intercept would be where 250x equals 6,400. And the y-intercept would be where 475y equals 6,400. So over here, the x-intercept would be where 6,400 divided by 250, that would be, 6,400 divided by 250, that would be at 25.6. So it could carry 25.6 pianos if it was all pianos. Or the y-intercept, 6,400 divided by 475, that would be at about 13.5. About 13.5 pianos, 13.47, to be more accurate, I suppose. All right, so I need to label my graph so x can be 25.6. So I can't go by ones, because if I go by ones, I will not get to 25.6. I could go by twos, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I could go by twos. Why don't I go by twos? I know I didn't do that on the answer key. So this would be 4, 8, 12, 16, 20, 24, 28, and that's enough. And then the y's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can't go by ones, so I'll go by twos again. And I would have 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and that's enough. So the x-intercept is at 25.6. Here's 24, here's 26, 25.6 is right about there. And 13.5, there's 12, there's 14, 13's in the middle, 13.5 be about right there. So my line would be a straight line between those, and it would be a solid line. Oops, that was terrible. I got to do it one more time. Oops, 25.6, 24, 25.6, right about there. And good enough. Okay, and then 0, 0 is a point I'm going to check, and 0, 0 is a solution because 0 plus 0 is less than 6,400, so I'd be shading this side of the line. And there's my graph. Now it does ask me, will 12 refrigerators and 8 pianos overload the truck? So I could take 12 and 8 and plug them in for x and y, or I could look and see if 12 and 8 is actually on my graph, and it turns out that the point 12, 8 is slightly above the line instead of below the line. So because it's above the line, no, it will overload the truck. It is not part of the solution, right? All right. By the way, this would actually be a discrete graph probably, because you can't carry half a piano or half a refrigerator. So we might talk about in class why that's a discrete graph, or what impact that has on the graph. All right, when graphing an inequality, can I always use 0, 0 as a test point? And the answer, no, not when it's on the line. So what do you do when that happens, when 0, 0 is on the line? Well, obviously, pick a point that is not on the line. You are allowed to pick any ordered pair you want. 0, 0 is just a convenient one. You could pick 1, 1, or 1, 0, or 0, 1, or 5, 17, really. Any ordered pair you want. All right, that brings me to my story problem here. So if you've read the problem, the question is, how much of each milk should I use? So I'm going to let X be the ounces of, which one's the first one? Is it Kroger or Meyer? Kroger. So the Kroger milk, which is 25% chocolate. Kroger milk, and that is 25% chocolate. And then I'm going to let Y equal the ounces of Meyer milk, and the Meyer milk is 17% chocolate, right? And I want to mix these two together, and I want to make 64 ounces, and I want those 64 ounces to be 20% chocolate. That's what I want my mixture to be. So, the first thing I'm going to do is I'm going to pour X ounces of Kroger milk plus Y ounces of Meyer milk into a container, and I'm going to have it add up to 64 ounces. And the second thing I'm going to do is calculate the amount of chocolate in each thing. So the amount of chocolate in the Kroger milk is 25%. So 0.25 times X would be the amount of chocolate in the X ounces that I use of Kroger milk. And the same thing goes for the Meijer milk. It'd be 0.17 times Y would be the amount of chocolate in the Meijer milk that I'm using. And in my mixture, it is 20%. So I'm going to multiply 20% times 64, and that would be the amount of chocolate in the 64 ounces of the mixture. And that's my two equations. And I could have gone ahead and multiplied the 0.20 times 64. I think that works out to be 12.8. So now I'm ready to solve this. I choose to solve it by the elimination method, but you could use the substitution method. I'm going to go ahead and multiply this first equation by negative 0.17. That gives me negative 0.17x, negative 0.17y, and I need to multiply negative 0.17 times 64, and that gives me negative 10.88. And now I'm ready to add these equations together, and I will have the y's cancel out. And I will have 0.08x equals 12.8 minus 10.88, which is 1.92. And then obviously, if I divide both sides by 0.08, I would get x equals 1.92 divided by 0.08, and that turns out to be 24. So that tells me 24 ounces of the Kroger milk. And if I plug that back into the first equation, you could practically do that one mentally. 24 plus y needs to equal 64, and so y would equal 40. And so now I can go ahead and write my therefore statement, and you probably don't need me to write it. Therefore, you would use 24 ounces of Kroger milk and 40 ounces of the Meijer milk. All right, our last problem is very similar to number 10. I have two perfumes that I am mixing together. I want to make a 3-ounce bottle of perfume that can be sold for $63. Whew, perfume can be very expensive. You'll find that out. Let's see. I'm actually going to use A and B. A is going to equal ounces of perfume A. And I will have B equal ounces of perfume B. So, as is typically the case, since I want to make 3 ounces, the ounces I use of perfume A plus the ounces I use of perfume B need to add up to 3 ounces total. And then comes the price. All right? I want the price to be $63. Well, what's the cost of perfume A? Perfume A sells for $15 an ounce. So if I'm using A ounces of it, then 15 times A would be the cost of A ounces. Perfume B sells for $35 per ounce. So if I'm using B ounces of it, then 35 times B ounces would be the cost of B ounces. And when I add those together, that needs to equal my total cost, and my total cost is $63. Notice that's not $63 per ounce, like 63 times 3. It's just a total of $63. And I now have my two equations. And I would solve it by the elimination method then. I would probably multiply this one by negative 15. So that would give me negative 15a, negative 15b, and negative 45. I can go ahead and add those together, and I get 20b equals 63 minus 45, which is 18. And if I go ahead and divide both sides by 20, I end up with b equals 0.9. So I'm going to use 0.9 ounces of perfume B. And I'd probably go ahead with this and go...
Good morning. Could I please have Jaheim Williams
Well,
to
hold
the
on
office?
for that.
Jaheim?
I'd probably go ahead and put into that equation A plus 0.9 equals 3. And if you subtract 0.9 from both sides, you get 2.1. So my therefore statement would be, therefore, you would use 2.1 ounces of perfume A and 0.9 ounces of perfume B to make the mixture. All right, hope that helps.